Megan Amsler, and I'm the Executive Director of Reliance, a women-led nonprofit based in Catawba, Massachusetts. I've been involved in renewable energy since 1996 and offshore wind since 2002. I'm a global wind organization certified instructor to teach basic safety training and have been doing this at Mass Maritime Academy. I'm very excited to talk with you today about offshore wind, especially given all of the focus on climate change and transitioning to a low-carbon economy to help reduce our greenhouse gas emissions and stem the negative impacts of climate change. I wanted to offer a brief overview of what offshore wind is, where development is being planned, and what trainings are available in the region for people interested in exploring jobs and careers. My first slide shows on the left turbines at Block Island Wind Farm in Rhode Island. This is the first offshore wind farm in the US. The photo in the middle shows a transition piece of a wind turbine, which is the part that attaches the foundation to the turbine itself. This is the piece that workers must climb up to reach the turbine. The photo on the right shows a worker doing maintenance on the tower, hanging from ropes above the water. So as you can see, much of this work is out on the water and requires skilled workers. This slide shows lease areas in federal waters along the eastern seaboard that have either already been leased by developers or one which are in the queue to be auctioned off by the Department of Interior through the Bureau of Ocean Energy Management. The projects in our area are south of Martha's Vineyard and Nantucket. There are 4 lease areas off of Massachusetts and one in the area of mutual interest of Massachusetts and Rhode Island, as shown in red. The purple areas are in New York. The Skipjack project off the Delmarva Peninsula in Delaware is red, and the green projects are Ocean Wind in Maryland. Together, these projects make up a large amount of offshore wind. So why are these projects proposed in these areas? Let's have a look at this next slide. This is a wind resource map done by the US Department of Energy. The redder the area, the greater the wind resource. Wind projects must be built where the wind is, since it's the fuel for the turbines. Wind spins the blades of the turbines, which turns the generator to create electricity. And we know that the majority of the American population lives, works, and plays along the coasts. The East Coast is a good place to start with the development of offshore wind. As the waters are relatively shallow, the wind resources are amazing, and the demand for electricity is very high. I should also mention that climate and energy policy from many of the states along the East Coast is requiring more electricity come from renewable resources to help stabilize costs and reduce greenhouse gas emissions. Let's look at this next slide. So with all of these projects planned, it is anticipated the development of offshore wind will be going on over the next 25 years. In the US, we are just in the beginning stages of developing the industry and the workforce to serve the needs of offshore wind. There are numerous places where people can get training depending upon their interests and skill level. This slide shows a number of those facilities. So we have the University of Delaware has their wind skill program, which is aimed at professionals. We have the UMass Amherst Offshore Wind Certificate Program. There are programs at UMass Lowell in their engineering department. We have Mass Maritime Academy, which has, as I mentioned, the Global Wind Organization training, as well as a really nicely aligned major of energy systems engineering that very well intersects with the needs of the offshore wind industry. There's Bristol Community College's Offshore Wind Certificate Program and partnership with ACE-MV, which is their adult education program. And then there's Cape Cod Community College courses in offshore wind as well. So this next slide shows working at heights and rescue from heights. This is one of the major needs of training for people working in this industry. And from a safety perspective, it's essential. At Mass Maritime, we have a climbing facility where we teach the Global Wind Organization working in rescue at heights as part of the certification program. As someone who was, and continues to be, scared of heights, I challenged myself to become an instructor and trust my equipment. I love teaching, and this is a great way to show people some of the aspects of working in a wind turbine. It is challenging and requires us to have a zero harm attitude in our work ethic. As I noted in the first slide, making a transition to the wind turbine is necessary when working offshore. Workers most often make that transition from a vessel to the transition piece. This can be one of the most dangerous aspects of the job as sea conditions can change. We are dealing with tidal currents, wind, and weather. Again, at Mass Maritime, there is a training facility located at the end of the pier where we have a mock transition piece used to train people on how to make a safe transition from the vessel to the transition piece and climb safely. We also conduct rescue descents into the water from this tower, which is really exhilarating. This is all part of the sea survival module of the Global Wind Organization training. Here we see underwater welding, which is on the upper left. This is necessary during the construction phase of projects. The Piledrivers Union is currently training their workers and apprentices to do work in the offshore wind sector. Many of the people who work on vessels offshore, who also work on wind turbines that are located beyond a 30-minute boat ride to medical attention, are also required to take a course in helicopter underwater egress training, or HUET. It is basically how to get out of the helicopter should it go down. There is an amazing training facility in Groton, Connecticut, where people can go to get this certification, and that is shown on the photograph on the bottom left. Remotely operated vehicles are also part of offshore wind, and the Woods Hole Oceanographic Institute has labs where engineers make and test these devices, as well as training programs that teach people how to operate them. That can be seen on the bottom right. So here is a quick overview of the skills needed to work in the various phases of building offshore wind projects. The photo on the left is showing the people on the transition piece waiting for the lower portion of the tower to be lowered by crane and then secured. The middle photo is welding, pretty self-explanatory. And on the far right, the photo is showing a technician working on the hydraulic system up in the nacelle of the turbine, which is where the generator is located way up at the top of the tower. And as we can see from the various categories here, we have planning and development, we have construction, and then we have operations and maintenance. And so what you can see from this, there are multiple aspects and sort of points of entry, if you will, if you are looking at ways to take your skill set and apply them to work in the offshore wind space. Ports are a big part of the wind industry. The turbine components are huge and often need assembly. As you can see from the photos below, welding, logistics, heavy lift crane work are just some of the things done here. And of course, we need to think about what are the skill sets that folks need in order to be part of this workforce. So many of them offer jobs that are entry level and require basic skills. Then we move up into a more technical type of industry, welding, assembly, crane operator, so more of the heavy lift type of things, construction related. And then of course there's quality assurance and quality control. So where we have things that are being assembled, we need to have the ability to have folks come in and check the work and make sure that it is ready to go and meets standards. There's also environmental health and safety compliance issues and coordination and management roles. These jobs require a high level of skill and training in how things go together, safety aspects, and technical repair and maintenance, as you can see from the person on the ropes repairing the fiberglass of the turbine blades. We also have, in the second photograph down, we have cable work. So there's cable laying and cables coming from offshore and making landfall. So we have lots of technical construction jobs here. The photograph on the top is another example of a heavy lift, and there's a tower section that is actually being lowered down onto another existing tower component. And you can see, just from the scale, the people are in there, and they are waiting to help with that assembly. I think it's really important to understand that vocational and apprenticeship skills are hands-on exposure and experience, and they are the best ways to make a pathway in and excel in these roles. Again, as I mentioned before, environmental health and safety, design engineers, construction managers, survey engineers, and operations and maintenance managers and technicians are all part of this workforce. So operations and maintenance of offshore wind turbines requires workers to be offshore for work. It requires working at heights in confined spaces with hydraulics, mechanical and electrical systems. It requires great teamwork and a positive attitude. As you can see from the slide, we're talking about a more highly skilled, from a technical perspective, workforce. Health and safety certifications are required for entry into this industry. And on-the-job training is required because every wind turbine manufacturer has proprietary equipment that you as a worker need to be trained on. So they do this on-the-job training, which is excellent. And you have to have a willingness to travel and to work on land-based wind turbines, as well as thinking about the fact that in the beginning, we don't have a ton of wind turbines located offshore. So that is one way to actually gain experience and expertise in this field, in this industry, by working both offshore and onshore. And as our industry matures here, we'll certainly see that shift from land-based to the work being more offshore. Just to show you, speak to the pictures here, people are going to work on vessels. So the middle photograph just shows that these guys are headed out to the wind turbine. And then once, on the far right, you can see that once they arrive at that wind turbine, you can see the vessel down below. So they have made that transition from the vessel, the crew transfer vessel, and then the person is climbing up the ladder to get to the platform. So these are all, I would say, very arduous and requiring a fair amount of skill and bravery, frankly, and that's just the way I look at it. Okay, so on another side of this industry, we have work that is considered back office work. So things that get done behind the scenes, and work on project planning, development, and even policy would fit into this category. There are certainly workers who have spent part of their careers doing the technical things in the field who come back to work in the back office, leveraging their expertise in the industry. There are a lot of opportunities to work in this space, from engineering, finance, procurement, communications, etc. This is also one of the places where you see a strong commitment to environmental health and safety, that basically that whole philosophy has to be saturated throughout the workforce. And so it exists, and you are trained in that as well when you're working in the back office, not just out in the field. And there's a very diverse amount of jobs and career opportunities here. So there are many jobs in the offshore wind industry that require a background in science. Some of these can include geologist and benthic surveyor, an avian specialist, which is looking at birds and the flight patterns of birds, a marine mammal specialist, so looking at habitat as well as the diversity of species that exist within the lease areas and species that may travel through the lease areas of the wind farms, so that we have a sense of how during construction and operations, how the maintenance of the buffers and acoustical impacts are actually mitigated to help protect the marine mammals. Oceanographers, geophysicists, marine biologists. This is just an example of the type of jobs and internships that one can really utilize to explore the overlap in offshore wind. Pathways that leverage engineering. Engineering, I find, is always a really exciting and kind of mystical for lots of people. I know a lot of the work that I do is talking with students and mentoring students. And when the term engineer comes up, there's a lot of mystery around it. And so a lot of time is spent in terms of discussing what do electrical engineers do, what are mechanical engineers up to, what do civil engineers do, how about from an operations and maintenance and managerial and supervisory capacity, how does one use engineering? And I find it's very interesting to seek out people. We have a lot of engineers in this region, and to actually come up with questions that you think that you might be interested in, how does that overlap? Because I really do think that there's an opportunity to take away some of that mystery and find out if engineering is really something that you might be interested in. Some kids say, I was really put off by, I thought this was going to be a really, I'm not mechanically inclined, and therefore I thought I couldn't be a really good engineer, or I kind of don't love math. But there's really a lot of opportunity to have this be an exciting field that might actually not be what you think. So I just encourage people to explore this. And I just wanted to show this next slide here. This is a blade testing facility. So we have one of these in Massachusetts, up in Charlestown. And wind blade manufacturers bring their blades to these facilities and actually test them before they're put out, before the design is actually put out for full manufacture. And I always take students up there so that we can have an opportunity to see what's going on within the industry. And this is a really neat place because they are literally testing in an accelerated fashion. They're testing these blades to fail. And so we learn a lot every time we go. And you can really see so many of the phases of I don't want to say construction, but this is manufacturing, right? This is design that goes into, so research and development is the term I'm looking for. So this is definitely a part of research and development that intersects with engineering. So before something is ready for prime time out in the field, it comes here to go to through a rigorous testing. So this next slide is to really talk about folks who are interested in business or economics. And again, there are lots of skills that are necessary in terms of thinking about how a project goes together. So these can include analytical and systems thinking, which is really looking at the whole project as a system that's all interconnected. You need the ability to understand technical material, understand the drivers behind the economics, and the larger issues of how the environment and climate play a role in the economics of large projects that are offshore wind. It also calls upon you to be a team player and make sure that you are committed to having things run smoothly, on time, and on budget, because we're talking about really big projects with really big budgets. So for this field, some roles can be filled with solely a technical certification, or you can have experience or a degree. So project planning, sales manager, offshore coordinator, project economist, investment manager, or an analyst. Those are just some of the examples that I've put out here. So this is definitely something that's near and dear to my heart, is internship opportunities. And I think that students who are really interested in any part of engineering, science, technology, engineering, and math, having an internship opportunity can really help make or break whether you decide to go forward in something or whether you decide to pivot and go in another direction. And I can say from my personal experience that learning that something is not what you want to do is just as valuable as learning what you do want to do. And I just want to call out the Massachusetts Clean Energy Center for their amazing internship program, which can be found on their website. It's for college students, and they offer paid internships for summer and then part-time ones for fall and spring semesters. And I have been hosting interns for the last 10 years. And I usually take 2 interns and we go on field trips, we learn about renewable energy technologies, we build stuff together, and we stretch our minds to do good for the environment. And there are other internship programs out there, and I certainly encourage people to explore those. And if you are interested in these programs and need help finding information, please reach out to me. I am happy to help you with this. And thank you so much for your time today. If you have any questions, please do reach out. My information is right there.